So I'm going to do some Gaussian elimination on this. The idea behind Gaussian elimination is I'm going to take a variable, eliminate it twice, and then do elimination again. So this is just repeated elimination. So I'm going to choose any variable I want that I'm going to try and knock out twice. So as I'm looking, I think the easiest one to eliminate is going to be x, because if you look at the first and the third are already going to knock each other out. So I'll do it off to the side in purple here. The first and the third equations, x plus y minus z, is equal to -4, and negative x plus 3y minus 2z is equal to 1. So you'll notice that if I add straight down, my x's go away. So y plus 3y gives me 4y. Negative z minus 2z is minus 3z. And then 4 plus 1, or I'm sorry, negative 4 plus 1 is negative 3. So I have eliminated x. Now what I'm going to do is I'm going to hold on to that, because I need to come back to my original three equations, and I need to eliminate x again. So I'm going to choose any equations I want. I'm going to go with the second and the third. I'll do these guys in blue. So you'll notice that the x's don't automatically knock each other out. But if I multiply the bottom row by 3, then I will have 3x and negative 3x, and they will. So let me go ahead and do that. Let me write out the second equation, because that is untouched. 3x minus y plus z is equal to 0. And as I come over, I'm going to multiply the second row by negative 3. So what I'm going to have is negative 3x multiplied by 3, so I'm going to have 9y. Negative 2z, so I'm going to have minus 6z. And 3. Now again, if I add straight down, my x's are going to go away. That's the point. So I have negative y plus 9y is 8y minus 5z is equal to 3. Now if you look at what we have here, is we have two equations with two variables. This goes back to being a normal equation. So let me write them over here. So I have 4y minus 3z is equal to negative 3, and I have 8y minus 5z is equal to 3. So I'm going to try and do elimination again. If substitution strikes your fancy, you could do substitution here. Now I'm noticing that if I take the top row and I multiply it by negative 2, that would make the y's eliminate. So let me just write it underneath. 4y times negative 2 gives me negative 8y. Negative 3z times negative 2 is plus 6z. And negative 3 times negative 2 is positive 6. So I can add straight down. My y's are going to cancel out. Negative 5z and 6z is 1z. And 3 and 6 is 9. So that's perfect. I have one of the three variables that I need in order to get an answer. So what I'm going to do is I'm going to take this and I'm going to plug it into either of the two equations that I got after eliminating one of the variables. I'll go ahead and plug it into the first one. So I have 4y minus 3z, but I know what z is. I know that z is 9, is equal to negative 3. Now I'm going to do some quick math here. 4y minus 27 is equal to negative 3. If I add 27 to both sides, I'm going to get that 4y is 24, and therefore that y is 6. So I now have two of the ones that I need. So what I'm going to do is I'm going to take both of these and plug them back into one of the original three equations. I'll go ahead and do it into the top. So I have x plus y, but I know what y is. I know that y is 6. Minus z, which I know is 9, should be equal to negative 4. So in other words, x plus 6 minus 9 is minus 3, is equal to negative 4. And if I add 3 to both sides, I get that x is equal to negative 1. So there are all three of my variables that I needed to find. If you'll remember that your answer should always be a coordinate point, and they always go in alphabetical order. So I have x, comma y, comma z, or in other words, negative 1, comma 6, comma 9.